So in this presentation we're going to look at a confidence interval. Now a company organizes two evening courses, one on stock market trading and the other on spread betting. For a sample of 100 clients, 60 of them would choose the stock market course. Now what we're asked to do is compute the 95% confidence interval for the number of clients, the percentage of clients that would prefer to work with that would prefer the stock market course. Now we're going to work in percentages or proportions. So essentially what we're going to do here is remind ourselves what the general structure of a confidence interval is. Just as a remark, it's a 95% confidence interval. So the first off, let's actually get point estimate. There we go. Plus or minus the quantile from tables times the standard error. Okay, so it's we have to perform this calculation here. So we're going to standard error times quantile, and then plus or minus the from margin error of the point estimate. Collectively, we'll actually call this the margin of error. It's not actually particularly relevant in this question, but the product of those two terms would be called margin of error. So what we're going to do now is actually look at the point estimate, and here the point estimate is the sample proportion. And the sample proportion, I'm actually just going to deal in proportions just for the sake of simplicity. You can go sample percentages as well. P hat equals 60 divided by 100. And there we get 0.60. Okay, so that's the first thing we have to calculate, the point estimate. Okay, the next thing we have to do is calculate the quantile. Now this is actually should be straightforward enough. We know it's a 95% confidence interval, CI for confidence interval, and we also know it's a large sample. So I'm going to just sort of say here that the quantile is 1.96. Now, if you're not quite sure where I've got that from, it's probably best looking at some of my other videos just to be sure. It actually, if you are reasonably familiar with it, good. Or you were expecting it, good. You should sort of see that number crop up quite a bit, 1.96. The last part is the standard error, and here we require a little formula. So the standard error for p hat is calculated as, this is from the back of the exam paper, square root of p hat by 1 minus p hat, complement of p hat, all divided by the sample size. So we're going to work that out on the next slide here. So again, standard error for p hat, I'll just write it out again. P hat 1 minus p hat divided by the sample size. Now remember that p hat was equal to 0.60. 1 minus p hat therefore is 1 minus 0.60, and that is equal to 0.40. And up here we are told the sample size n, and therefore n is equal to 100. Now, so this is a bit of calculator work here. That it quickly turns into a bit of calculator work. 0.6 times 0.4 all over 100. That is equal to the square root of 0.0024, and that is equal to 0.049. So that is the third component of the confidence interval. So we're actually ready to put them all together now and compute our 95% confidence interval. So let's go to the next slide here. So it is, again, point estimate plus or minus quantile times standard error. Now, quantile times standard error, that is equal to 1.96 times 0.049. The point decimal is 0.60. Okay, so what we have here is, so what it works out to be is just a bit of calculator work. It is 0.60 plus or minus 0.9604. Just to be write it to quite a few decimal places. You can actually simplify it later on. That works out to be 0.50396. That's the lower bound. That's when we minus 0.6 minus 0.09. And when we add them together, we got 0.69604. Okay, so that is our confidence interval. It's roughly equal to 50% to 70%. Okay, so that is the answer to that question. That is the 95% confidence interval for the proportion. And you can just check with your lecturer and your lecture notes just to see how precise the answer should be. Okay, that ends the presentation.